Alright, what do we have here? Okay, let us talk about the dynamics of stress and strain. It falls under the topic of elasticity, which is and what can we learn about it from what can we learn from elasticity that applies to relationships. Okay, if you stretch anything, it would it it would change in shape. A deformation would take place. If you even give force to a pen, a deformation would take place. Although we don't see it, but the atoms inside, they they are pulled together by an intermolecular force. Kind of, if you put together all pieces of balls and tie them up with strings, and if you pull or stretch or bend it or compress it, it will stay in the same place unless you have given enough force that would deform it completely and change its physical properties. So, alright, what do we know so far? We know so far that elasticity is the property of an object to regain its original shape after some pressure is applied to it, and because of the pressure we applied on that object, and a reverse, let's just say a reverse force, a force in the opposite direction is formed. It is equal in magnitude to the force we applied, so that's why it regains its original shape. But and and stress, this is the corresponding ratio of the change of the volume or length or anything to that of the original length. For example, if there is a scale of 10 meters, and if I stretch it by 12 meters, now the ratio of the change, which is 2 meters by 12, 1 by 6. Okay, that is the stress. It doesn't have any unit since it's cut itself out, meters and meters. And it can be volume or anything. So what does this apply to relationship? Okay, now we know about stress, we know about strain. Stress is the, the restoring force per unit area when we apply a force to an object, and the stress is, the strain is the ratio of the change in length to that of its original length. Now, if we are going to draw a curve, the vertical line, we would plot the stress, and the horizontal line we would plot a we would plot the strain produced by the corresponding stress. So it gives out an interesting result that once if the object is stretched to a point, initially we would discover that it is a linear relationship, which means it would give straight line. The stress and strain, like how much force I apply, would be proportional to the change in the stress. But what if I stretch this rubber so hard? I can't, because I don't have much strength. But if let us just theorize that I can pull this rubber to its elastic limit, then it will break. Same thing applies in relationships. So here is where is my graph of, okay, I'm gonna take it out. This looks like the stress strain curve, which is really hard to understand, but let me simplify it for all of you. Okay, now this is the fun part. Okay, I'm gonna just draw two straight lines. Oh, I know this is not a straight line, but just imagine, and on the other hand I'm gonna draw one line which is for your relationship dynamics. Suppose this is you, and let me just your effort, and this is their reaction, their reaction, and this is the stress, and this is the strain. So what happens when we pull when we pull an object, when we apply some pressure? So a strain is produced inside, and there is the strain, which is the change. And when we plot it initially, uh, it has a linear relationship, which means how much force you apply, that would be the amount of things withdrawn, almost similar to Newton's third law of motion. Through every action there is an equal and opposite reaction, and even in relationship, this is your effort and this is their reaction. You are a boy or a girl, then this is your boyfriend or girlfriend. If you give them rose, they would give you rose, and if you are having an effort which is not too high, not too low, then their reaction would also be the same, just as the same as the stress and strain curve. But what happens when you apply too much stress, and what happens when you apply too much effort? So their reaction starts to be a bit more and more, and even in here their reaction starts to be a bit more and more. If you press, once you reach this limit of doing too much, of applying too much stress, then the strain is produced so much, even for little amount of stress, even for little amount of effort, they are about to break off. And once you reach a certain point, say B, this is called the elastic limit. Your material, any material, a wire, a rubber, or anything starts to break off, that is called the elastic limit. And even in relationship, when you put in too much effort, then your relationship starts to break down. Let me just say that is the iceberg, the iceberg for the Titanic, the iceberg for the Titanic. So it's kind of it's kind of fun when we look deep into nature and realize we can learn a lot of things from this. Like for example, the stress and strain curve, and your effort and their reaction. At first, if you give in enough pressure, then the strain would be produce more and more and more and more. Your effort, if you give in, you will produce more and more and more. So you don't want it to reach here, the breaking point of your relationship.